The focus of today's presentation is going to be on building Burp Suite extensions using the Montoya API and the programming language Kotlin. The idea for this talk came after some of the Portswigger moderators encouraged me and some other people to try Kotlin. And it took a while for me to actually give it a try. I was pretty resistant at first. But somewhere along the lines, they wore me down and convinced me to try out using Kotlin to build a Burp extension. And I was surprised to find that I really, really enjoyed it. It was really fun to use Kotlin. And not that Java was not fun to build Burp extensions with, but Kotlin was more fun. And I wanted to share kind of some of that excitement about Kotlin with other people through this presentation, so other people might consider giving it a try. I also wanted to make it easier for people to try Kotlin. And so this presentation, I'm really going to focus in on how Kotlin works in IntelliJ and how you get to building a Burp extension. And I'm also providing a template so that you don't have to worry about some of the plumbing and setup. You simply clone the template and you're ready to start building your extension. But I realized after talking to other pen testers that that's not enough. So having a blank template that is greenfield, new development for an extension is a little bit overwhelming sometimes. When you're in the middle of a pen test and you realize you need to build a Burp extension, a lot of people worry that it'll take too much time, that maybe it won't work or they don't know how. And instead of attempting to build a Burp extension, they just tough it out. A lot of the workflows for testing some custom applications involve custom encodings or just weird things that you would normally have to do something like in repeater, copy something out of repeater, maybe a specific value from a specific field, paste into another tool, maybe do some encoding, modify it, re-encode it, copy and paste it back into repeater, and then send your request and see if it worked. And that's really time consuming. It's demotivating. It's frustrating. And if you continue with that workflow, you're going to find that you just don't go as deep in the application. You get frustrated with testing things. You maybe give up and just don't get the level that you want in that assessment. And so if you can build a Burp extension that puts all that tooling right into Burp Suite and does it automatically, then you're going to have a lot more fun doing that assessment and you're going to be able to go a lot deeper, a lot more comprehensive. So to help address that, in addition to a greenfield kind of blank template, I also have sort of starter extensions. They're example extensions that provide kind of how you would do certain things in a Burp extension. And it focuses on common problems or challenges you see in an assessment. So one of the demos today is going to focus on one of those. We're going to go through and look at session macros and being able to do some custom session stuff that just can't be done with vanilla Burp Suite. It needs a little bit extra help through an extension. So before I do that, a little bit about me. I'm a pen tester. I've been doing app pen testing for 18 years. I work for Virtue Security, where we do app and cloud and network pen testing. I'm also one of the Discord moderators, and I have a number of extensions on my GitHub page that you can check out. Most of them are for just my personal use. I had a specific need in a project and I built something, but others are more general purpose and might fit the needs of lots of people. I also have one extension in the BAP store for AWS Cognito. So in Burp Suite, there's a lot of times when just simply using repeater and intruder and scanner as is may not be enough. And you may need some way to kind of extend it somehow. There's a lot of options for doing that extension. You can use session handling rules and macros, and those are going to help you stay logged in or to re-log into an application, or it's going to help you use the most current cross-site request forgery token or something like that. You have BAMDAs. BAMDAs are pieces of Java code that you can use to filter a list of requests and responses in quite a few tools nowadays, but proxy history, logger history, sitemap. But you can also use BAMDAs to add custom columns and extract out information from a request or response. The example that I like to use is SOAP requests. When you look at a list of SOAP requests in the proxy history, you can't see what SOAP method it's using. You can't see in the parameters. You have to click on each and every request to find out where it's going and what it's for. And if you could write a piece of Java that pulls out the method, then you could quickly find the requests you're interested in. Another extensibility option is bchecks. They're for writing scanner checks, active and passive scanner checks in a kind of a pseudocode type language. And then last, our focus is going to be on extensions. So we're going to talk just about extensions and specifically the Montoya API for extensions. There is an older extender API. It's been deprecated. It's no longer receiving new features. And it actually lacks a number of features around WebSockets, around some better helper and utility methods, JSON deserialization, saving settings to the project or Burp Suite itself to be remembered the next time you open it, and things like that. And a lot of people are familiar with the extender API because they wrote a lot of their plugins in Jython. Ended up being pretty popular. We're going to focus on Montoya API. It's recommended that that's the API that you use to write new Burp Suite extensions. And that API only supports Java, at least directly. So you can't necessarily write Jython or JRuby, although I've heard some people talking about ways in the Discord where that might be possible, but I haven't actually seen it fully fledged. So we're going to focus on extensions and Montoya API. But this presentation is about Kotlin, and we haven't said anything about using Kotlin to build Burp extensions. If I go back to the previous slide, the word Kotlin does not appear anywhere. So how is it that we can build Burp extensions with Kotlin when it's not actually supported by the Montoya API? To answer that, let me talk more about what Kotlin is. So Kotlin is a programming language. It's its own programming language. It's developed by JetBrains and it's open source. It is now the official, as of 2019, the official language for building Android applications. So if you know any Android developers who started after 2019, they are probably using Kotlin to build that. But the key point I want to point out is Kotlin is fully compatible with Java. And that could mean a lot of things. But what I mean in this case is when you build a Kotlin application or library, it compiles down into a Java class file, or you can package it up into a jar file. And what Burp Suite needs to run an extension is a jar file. And so since Kotlin can compile into Java class files, packaged up into a jar file, you can use it to build extensions for Burp Suite. The other key thing about it being compatible that makes it really important is Kotlin can use Java libraries. So you have a Java standard library. You have Java libraries that are already existing, like org.json or some of the other libraries out there. All of those work in Kotlin. You can just use them directly. You don't have to do anything new. But in addition, you also get the Kotlin standard library and any Kotlin libraries or frameworks other people have written. So you get to access both Java and Kotlin from Kotlin. You can even intermix Kotlin and Java in the same project and not really have to do anything special to differentiate there. So that's really neat. So what makes Kotlin different from Java? Why might Kotlin be something you want to try? So a lot of people find Kotlin to be more concise and efficient. They can accomplish what they're trying to accomplish in Kotlin faster than what they can do in Java. And Java is getting a lot of new features or ways to streamline things all the time. It's becoming more like Kotlin or really other languages as it continues to mature. But Kotlin has still kind of got an edge on that. It seems to be quicker to do something in Kotlin than it does in Java a lot of times. Another thing people get excited about for Kotlin is its built-in null type safety. So at compile time, if you have a potentially nullable value or variable, the compiler will not let you compile it unless you've checked to see if it's null. So it eliminates most null variable dereferences, but occasionally they can still happen. It's not foolproof, but it's pretty good. The other thing that Kotlin has that Java doesn't yet have, but is actually on the roadmap and I think is in sort of like a beta stage, is string interpolation for people who like that. Kotlin has better support for Lambda functions than Java. And then it has async and await features through coroutines. Java is also working on some kind of async await structured concurrency, but it's in beta. Right now we have virtual threads, but not structured concurrency. But Kotlin does have that. And then next we have extension functions, or if I think about Ruby, it's called monkey patching. And that is we can take somebody else's library. We don't have the source code. And we can sort of overlay functions on top of their classes as if they were our own, and we can add additional functionality to it as if it had already existed in that library without having access to the source code. And I'll demonstrate one of those later on in the presentation. So I think a lot of times it really comes down to your personal preference. What do you enjoy? And so a lot of people who try Kotlin, they really enjoy it and they get excited about it and they switch to Kotlin for most things. Some people don't end up liking Kotlin and they like Java better, and that's okay too. But it's worth giving it a try if you're building a Burp extension. So before we get into demos for the template and then the example extension, we need to talk a little bit about how Kotlin syntax works. We're not trying to make anybody experts at the moment, but I need to make folks familiar with a little bit of the syntax so when we're looking at code, it makes a little bit more sense. More research is going to be needed if you actually use Kotlin, and I have some resources at the end of the presentation to help you. But we're just going to get proficient at just reading it a little bit first. So I'm going to start with functions. Function declarations look a little bit different in Kotlin than Java. For functions, they always start with the fun keyword, followed by the function's name, in this case circumference. And then inside the parentheses, the name of the variable comes first, which is radius. And then its type comes second after a colon, and this type is double. Finally, the return type for the function follows that outside the parentheses with another colon, and then the return type is double in this case. The body of the function can actually have two different forms. It can have it can look like a statement. So in this case, 2 times pi times radius equals the function, and what's returned from that statement is the return for the function. But it can also be defined in a more standard syntax where you have the curly braces and you have multiple lines of logic with a return statement that finally returns kind of the value for the function. So there's 2 different formats for it. Next is classes. At first, classes look to be the same as Java until you look closer at that first line. Starts out similar, keyword class, followed by the name of the class. But in that class declaration line, you have a variable. And it looks like a constructor, and that is kind of what you might think of, but there's a little more to this. In Kotlin, we don't tend to have class instance variables like we do in Java. So in Java, you often have like a class instance variable, and then you have a getter and a setter, maybe sometimes public, sometimes private, that lets you get access to that instance variable. A lot of times you're not necessarily messing with the instance variable directly, although you can. Kotlin just shortcuts that. In this case, we have a constructor that accepts the variable named radius of type double, and it's doing more than just accepting that. It's actually declaring a property, which is a getter and setter. It does have a backing field, but you usually don't interact with it in Kotlin. So we have a radius that has a getter and setter, and it's going to assign whatever you pass into the constructor to that property inside of that Kotlin class. So circle has a circle.radius, and you can say circle.radius equals something, or you can retrieve the value by saying circle.radius. And you don't have to have like a get or set. It kind of is implicit. Similarly, the second line down, private val pi of type double equals 3.14. This is also a property. It looks a lot like an instance variable, but or a class instance variable, but it is actually a property. Pi is a property with a private getter and setter. You cannot access it from outside of the class. It must be inside the class. And it has an initial value of 3.14. And then finally, we have a function circumference, which we talked about on the previous slide. The other thing I want to point out is when we create an instance of circle, so val small circle equals circle, pass in 5.2 for the radius. Notice that there's no new keyword, so we don't need that new keyword when creating an instance of a class. All right, last slide on syntax, variables, declaring variables. This is a little bit different. So we're going to focus on the second variable declaration in this slide first. Var, my favorite drink, of type string equals coffee. This variable declaration is going to work a lot like the variable declarations that you're familiar with. You can assign it a value. If you decide to change the value of the variable, you can reassign a different value, and there's no problem there. So the var keyword is the one that acts like other variables in other languages, or most other languages. That's contrasted with the first line, val my name equals Nick. We're using val instead of var, and val basically makes that variable, some people would call it immutable, some people would call it read-only. I don't really like either of those descriptions. What I would say is when you declare a variable, or when you declare it as a val, it's going to point at the instance of an object or a reference to an object, and the reference to that object can never change. So if we're pointing at the reference to the string Nick in memory, we cannot make my name point at some other reference in memory. It always has to point at that one. So in Java or Kotlin, when you reassign a string, the way it works is it allocates new space in memory, it puts the string there, and then it points your variable at that string. So we can't do that. So my name can never change into a different string, just because of how strings work in Java and Kotlin. However, if we go to the previous slide, we have a val, so this is supposed to be that immutable or read-only small circle, equals a new instance of a circle class with a radius of 5.2. We always will point at the same circle instance. We cannot change that, but only that part is, quote, immutable. The radius is declared a var, so it can be modified. So the same exact circle instance can actually have a different radius assigned to it later. We can say small circle dot radius equals 2 and change the radius of the circle to a 2. It's still the same instance of the circle. We're pointing at the same reference, but its radius has changed. And because of that, I think it's very confusing to some people. And so I don't like to say it's immutable. I like to be a lot more explicit about what's happening. It's okay if you don't grasp all that right now. What's important is that you know that there's a difference between var and val, and there's something about immutability between those to research it a little bit more later. Last thing I want to point out is about null, and I sort of skipped over this in the previous ones. It turns out that both my name and my favorite drink can never point at the null value. I cannot hold the null value. Only variables explicitly declared as nullable can point at null in Kotlin. So the third variable declaration, var where am I of type string question mark or of type nullable string, that's the only one that can hold the null value. And in fact, we assign null initially to it in this case. Now in Kotlin, if we try to use the where am I value variable without checking it for null, it's going to throw a compiler exception. It will not build. And so we need to check to see if it's null before we try to access its value. You can do that with an if-then statement. If where am I does not equal null, then do something. But there's actually some operators that's built into Kotlin to make that simpler if you want to use them. So on the last line of code, we have a where am I followed by a question mark. This is called the safe call operator. It's like a built-in if-then. It's saying if where am I is not null, then call where am I dot uppercase. That's what's happening there. If it is null, it's just going to bring back a null and nothing's going to happen. And so we have another operator to handle situations where the value is null and we want to return something different instead. And that's called the Elvis operator. It's the question mark followed by a colon. So if the thing on the left is null, the Elvis operator instead returns the thing on the right. In this case, it's the string nowhere. So when we run this code, we get Nick drinks tea in nowhere because the location is set to null. And we're using the Elvis operator to bring back a default value. All right, that is enough syntax for now. Let's get to some demos. We are going to start with the Burp extension base. And before I do that, let's look at a repository for where this is located. So on my GitHub repository, there is a project called Kotlin Burp extension base. And in this repository, you're going to find a whole bunch of information about how I set up this project for the first time, the different steps I did, the Java settings, the Kotlin settings, why I did it. You're going to also find references to some of those other example projects, of which we're going to talk about this one right here, the Jot token handler demo. Inside each of these projects, it tells you about which features of the API I'm using, and it kind of provides you with a starting point for those. And then there's a reference to another library that we're going to get to. If you want to know more about what's happening in the template, this is where you would go. But most of you don't need any of that. Most of you, all you need to do is go to this repository. You're going to go here and you're going to either clone the repository or download a zip. The zip might actually be easier, so you don't have to delete the .git folder. And you're going to use that as the starting point for your project. So let's pretend that we have downloaded a zip of this and we've extracted it and we've opened it, and now it's going to be the base of our project. I'm going to walk through what's in here and why it works and how it works so you can understand that. So we're looking at the Burp extension base project. And the first thing we need to talk about is the build system. The build system, which in this case is Gradle, is responsible for both downloading Java and Kotlin dependencies from, let's say, Maven Central. It could be your home directory. It could be other repositories. It's going to download org.json or whatever it is you tell it to get to include in your project so that you can use it when developing your extension. The second thing that the build system is going to do, or Gradle, is it's going to be responsible for compiling your application and packaging up into a jar file. And so we need Gradle to do these things for us. This is the same process for Kotlin as it is for Java. It works pretty much the same way. So this applies in both cases. So if you want to build a Java extension instead of a Kotlin one, everything we're going to talk about here is pretty much the same for Java. So first thing, I want to familiarize you with the key files for the Gradle build system that you may need to tweak. We're going to open the settings.gradle.kts file. And in here, really the only thing that you need to play around with is the name of your project. Once you download a zip and extract it and choose to use it as a starting point for your project, you're going to come here and change the name of your project to something meaningful to you. Second, we have the build.gradle.kts file. This file is what really configures everything about Kotlin and the build system. So we're going to use Kotlin, and we're going to tell Gradle that we want to use Kotlin version 2.1.0, which is the latest version at the time of the presentation. We're also going to include a plugin called the Shadow Jar plugin. And the reason this is needed is when we build jar files for Burp Suite expects us to package up all of our dependencies into that jar file. It's not going to go out to Maven Central and get them for us. It's not going to magically have them in its own class path. If we use some sort of external library that we have to declare down below, we have to have it packaged up into the jar file. So this Shadow Jar plugin basically creates a target that automatically packages that up. And I'm going to show you exactly where that is here in a little bit. Next, you're going to want to give your extension a namespace. So you would change this to whatever you'd like. Here you can change the major and minor versions of your plugin when you release it, or however you want to do that. And then down here, the key thing we're doing in the dependency section is telling it which libraries to go and download from somewhere. By default, it's going to download it from Maven Central. And the one that we want is the Portswigger's Montoya API library. This is the one that gives us all of that interconnectedness to Burp Suite. We have to have this in every Burp extension so that we can interact with the application. The way this works is it's going to go out to Maven Central. It's going to look for an organization called net.portswigger.burp.extensions. Inside that organization is going to be a library called the Montoya-API. And then we're going to ask it to download version of that library 2024.11. So it'll go and do that. Last, down here in the Kotlin section, we're going to tell Kotlin what JVM we want to target. We're going to target JVM 21. And the reason we want at least 21 is because 21 is what gives us Java virtual threads, which I've used in some of the other projects and is a really great way to do some things asynchronously if you don't want to mess with like async and await. It just kind of magically happens for you in most cases. The current public release of Burp Suite is also built against Java 21, although I think I saw some saying that soon they're going to be targeting 23, I believe. So you can up this when you see in the release notes, or I will up this in the release notes when I see that that's increased and we can target a higher version of Java inside of Burp Suite. So these are the files that sort of configure Gradle. How do we actually make Gradle go and do its stuff? Well, inside of IntelliJ, we're going to use this elephant icon on the far right-hand corner. And in here is a bunch of build targets. The first time you start up IntelliJ, you will not have these. When you first start it up, it takes IntelliJ a little bit to go through the configuration files and download the Gradle executable and sort of parse everything and figure everything out. And so you'll have to be a little bit patient waiting for that to happen. On the bottom middle section where my mouse is now is where there's going to be a bunch of processes running, and you can kind of click on them to see how far along it is. while that's happening. That way you can see if it's finished. Now, whenever you change the one of these build system files, you're going to need to tell Gradle about that. And the way you tell Gradle about this in IntelliJ is you hit this refresh button. When you hit this refresh button, it's going to reparse all the configuration files. It's going to run Gradle and then update all the tasks in here, update your code completion, download libraries, and things like that. So every time you change this, hit the refresh button so that it's going to get the latest version. Then when it comes time to actually build an extension, you're going to come over here and find the shadow group and double click on the shadow jar task. That's what's going to build your jar file that includes all of your dependencies. And again, this is what's provided by this plugin right here. So we're going to run that shadow jar. Actually, I'll go ahead and do it. We're going to run the shadow jar process. It actually takes a little while for the daemon to start up the first time, but then it stays running. And then we'll have a jar file that comes out. While that's going, I'll show you where that shows up. So your jar file, when it's done, is going to be found under your project folder, and then in build, libs, and then you're going to have a whatever the name of your project is, followed by the version number and a -all.jar. Make sure there's a -all.jar. If you don't see the -all.jar, then you've actually hit a different build target. You've produced a jar file, but it doesn't include the dependencies. You need to see that -all. And then the way we actually use this in Burp Suite is we pull up our extensions tab in Burp Suite. We're going to go down to the bottom. I'm actually going to remove the one I have. We're going to click add, and then we're going to go and find that Burp extension base -all. So that's going to be under your project file, folder, build, libs, and then the -all. We'll click on it. It does say extension type Java, which is just fine. And we're going to click next, and it's going to load. And we're going to come back to some of this output here in just a second. Okay, so we know how to build this. We know how to get the build system working. How do we actually write our code? We have inside the template a Kotlin class. Right now it's called your Burp Kotlin extension name. You would, when you do your project, you're going to rename this. And to do that, use the refactor feature. If you right click on it and go to refactor and then rename, you can give it some other kind of name. This doesn't just rename the file, it's going to rename the class inside of that file. And then if you had other classes that actually referred to it, it's going to update all those references as well. So change the name here, hit refactor, and it's going to update all that stuff. So let's look at that file next. So when Burp Suite loads your jar file, how does it know what to actually pull up, what to run? How does it figure that out? What it's going to do is it's going to open your jar file. It's going to process each of your classes, and it's going to look for a class file that has a Burp extension interface one that implements the Burp extension interface. This is a interface provided by Portswigger. It's from that library we reference down here. It's one of those libraries. And what we need to do is say, hey, this class implements Burp extension. And then if we control click on it, we can actually see what the expectation is for that interface. So if we implement the interface for Burp extension, we need to provide a function that's named initialize that accepts a Montoya API parameter. So if we didn't already have that, one way we can do that quickly in IntelliJ is we can click on the Burp extension interface, hit Alt Insert, and it's going to make some suggestions about what code you might want to generate. We're going to choose implement methods, and then it's going to say, hey, this Burp extension interface requires initialize method. Do you want me to stub it out? And I could click on it and hit OK, and it would create a stub of an initialize method for me. We're not going to do that here because we already have an example. So let's talk through the one we have. So Burp Suite loads your extension. It finds a class that implements the Burp extension interface, and then it runs this initialize method as its first task. It's going to pass in an instance of the Montoya API. But one thing that's confusing is it's coming from a Java context, and Java doesn't really differentiate between nullable and non-nullable parameters. So we have to declare this API as potentially nullable. If we ever did receive a Montoya API instance that was null, something really horrible has gone wrong, and we don't want to really keep executing code. Something has gone drastically wrong. We're probably gonna have to close Burp Suite, open it. I've never seen this happen, but if it does, it's just you're in an unworkable state anyway. So before we use this API parameter, because we're in Kotlin, we have to check for null. And to kind of prove that, I'm going to comment out a line of code, and then I'm going to go to the problem section, and it's going to show, if we double click on this, hey, we're trying to use the api.logging.log to output method, but we didn't check to see if API is null or not. And so it's not going to compile. There's a couple things we could do to check for null. We could use an if-then statement. We can use a safe call operator. But in this case, because we don't want to continue execution if that API is ever null, we actually want to throw an exception if that was null. And there's a built-in Kotlin feature to do that. This require not null method, what it does, actually if I hover over, I think it'll tell us, it'll throw an illegal argument exception if the variable it accepts is actually null. It'll also do the checking for null in there. And after doing that, the compiler is going to keep track of the fact that the API parameter has already been checked for null. After this line, we can use the API parameter without checking for null for the rest of the function. We don't ever have to check it for null again, because if it is null, there'd be an exception and it wouldn't continue anyway. So what we're going to do is we're going to check it for null. We're going to return the non-nullable API, and we're going to assign it to a property inside of our class. This is important because there's going to be other functions outside of this initialize function that need to access the Montoya API. We need to kind of like save it for later so that those functions can get to it. And so if I control click on this API property, we'll go up to the top and see that we're under the your Burp Kotlin extension name. And we have a property called API of type Montoya API, and it is not nullable. It's a non-null variable. Other functions will be able to access this. From there, there's something I learned from hours and hours of troubleshooting and frustration that I employed in this template. That is, we are going to log to output when we start loading our extension, and we're going to log to output when we finish loading our extension. The reason for this is most of the time when some kind of exception occurs in Burp Suite, you're going to get some kind of output in the error window. Go to that. There we go. You're going to get some kind of output in this error window. It's going to have a stack trace and tell you, but there are occasions where you will not see anything. An exception will occur, Burp Suite will swallow the exception and keep going as if nothing ever happened, but your plugin doesn't keep running. It just mysteriously stops working and you have no idea why. So one way to combat that is to log to output when you're loading your extension, and you'll be able to tell if it actually got all the way through this initialize method. If you see the started loading extension and you don't see finished loading extension, then it didn't even get outside of your initialize method. So last thing we're doing in our extension, this is again a bare bones kind of greenfield extension template. We're going to create a name for our extension. In this case, it's your plugin name here is the name of the plugin. You'd put whatever you'd want here. And this name appears in Burp Suite. If we go down here to our extensions tab and look at the installed extensions, we see your plugin name here as the name of our plugin. One other important thing to talk about is the order of these extensions matters. They're going to be executed from top to bottom. So if you need your extension to do something specific and you want it to happen first or last, you need to use this up and down button over here to change where your extension executes. These are not alphabetical order. These are in order of when you installed them. You need to move them around to make them make sense. Okay, next, I want to show you how to debug extensions when you're developing them. So one option is to do logging statements. You can, and I usually do put logging statements in all of mine, but that's not primarily how I debug. Oops. What you want to do is log the output, anything like the status as you go through your plugins, just so that you can kind of keep track of what's going on. You'll notice errors because of that sometimes, but the better way to debug this is to actually use breakpoints. And so to set a breakpoint, you can come over here in IntelliJ, click on the line number, and the red dot is the line you want it to stop on. And then you have to do a little bit of configuration for Burp Suite to get it to actually do it. So the way we do that is we're going to actually go to, I'm going to copy the path where this is at. Copy path. And there it is. Oops, that's not working. Let's try that again. Copy path / reference. Absolute path. So I have a file in my Burp Suite Pro installation directory called user.vmoptions. That's the file I'm editing. Inside of that file, I'm going to add a Java command line argument that's going to tell it to listen for a debugger to attach. So it's going to look for a debugger to attach on port 8700 on localhost. Once it does, it's going to be able to hit that breakpoint. This has to be on before you start Burp Suite. So if you already have Burp Suite open and you add this line in here, you're going to have to close Burp Suite and open it again before it works. So with that, when we, oh, sorry, I have to go back to IntelliJ first. Let's say we are ready to start debugging that extension. First thing we need to do is attach IntelliJ to Burp Suite as far as a debugger. To do that, we're going to go over to Run and then Attach to Process. And on my machine, it's going to be able to find that port 8700 is open and that it's looking for Burp Suite. It should work the same way on most people's setup. And all I have to do is choose that. It's going to come up with the debugging tools on the bottom. And now it's waiting to hit a breakpoint. What we're going to do is we're going to force it to hit the breakpoint in the initialize method. And I'm going to come down here to your plugin name here. I'm going to control click the check mark so it unloads and reloads the extension. And that's going to cause us to hit that breakpoint in IntelliJ, and it's going to switch to that window automatically. From here, you can actually interact with the different variables. You can actually execute some code if you need to by going to evaluate expression. You can kind of interact with your variables. You can explore what's inside there. So this is your primary method for debugging. You can also use things like step into or step over to go through your code one line at a time, things like that. Okay, so that's the basics of how this works, how to debug. Let's actually focus on a real plugin doing something for us in a pen test. We're going to this one. So we're going to work with this extension. So what I did is I kind of had the same starting point. I cloned that template from the GitHub. I renamed that your plugin name here class and made it, oops, sorry, it's this one, and made it Jot token handler extension. And then I don't think I have anything else in here. No, I don't. I didn't do anything with additional libraries or changes to the Gradle file. All of our extension is really, for the most part, in this Jot token handler extension. Let's talk about what we're trying to do though. We are going to interact with OWASP Juice Shop. So OWASP Juice Shop is an intentionally vulnerable application that you can use to learn pen testing or learn to exploit certain vulnerabilities in applications. And there's two functions we're going to focus on for our example. We're going to focus on, actually I need to turn something off before I do that. Okay, we're going to focus on an API endpoint for the users function, and we're going to focus on the login function. So when we interact with OWASP Juice Shop, some of the API recognizes that we're logged in based on an authorization bearer header that contains a JSON web token. Other parts of OWASP Juice Shop actually look for a cookie name token with the same JOT token. So depending on what you're interacting with in OWASP Juice Shop, you need one of these or the other. Now, when doing a pen test, a lot of times you will interact with the application using repeater or intruder or scanner, and you need to be able to make sure that you have the latest JOT token. And a lot of times that's easy to do with session handling rules and login macros. But in some cases, it's going to be a little bit more difficult. We're going to actually look at the slides to talk about how that works. So we talked about if you do a GET request to the /API/users endpoint, you're going to get a 401 unauthorized message. In order to successfully interact with the API, you're going to actually have to provide a token. And to do that, we first have to log into the application. So when we log into OWASP Choose Shop, go back and show an example of that. We're going to submit to the /rest/user/login endpoint a username and a password. In this case, it's a SQL injection payload. We're going to get back a response that has JSON, and inside the JSON, under the token parameter, authentication and the token, we have our JOT token that we need to provide to the application. So we get back our JOT token, and then we can use that in the cookie called token and in the authorization bearer header in order to authorize ourselves to be able to access the application. So if we're doing a pen test where we're going to interact with repeater a whole bunch and maybe intruder and scanner, we're going to need to paste in this JOT token every single time we have a new request in repeater to make sure that we're still logged in. That's going to get really annoying really quick. And so there's an option as a session handling rule to do this automatically. It's going to make our life a lot easier. We don't need an extension. We don't need to write anything special to do this. We can use session handling rules to be able to automatically append a new authorization bearer token and a cookie name token to every request. And we can enable that based on what tool we're using. And so if we log in once and we have a long-lived JOT token that's good for 8 hours, this may be all we have to do. Set a session handling rule to append this to intruder, scanner, repeater, and just do our pen test. However, it's pretty common for JOT tokens to expire and expire soon. Some JOT tokens do last for 8 hours, but some last for only 2 or 3 minutes. And so in the previous example, if we're interacting with the application through a repeater, we're going to need to update that session handling rule every 3 minutes in order to keep testing. And that's going to get really annoying really quick. Unfortunately, there's not an easy way to automate getting a new token and adding it in here with session handling rules automatically in Burp Suite. You can get really, really close. And the closest you can get is you can, for every single request, issue a new login request and then replace these tokens. But you can't do things like cache a working token and keep using it until you're done. And the problem with logging in every single time is it's just really slow. If you're trying to do that with a scanner and you have to make those extra requests, it's going to take forever. Same thing with intruder. If you're doing a couple thousand requests in intruder, it's just going to take a long time. So you'd like to be able to cache a working bearer token and use it until it's no longer valid. So how are we going to do that? We need to write an extension to help us. And this is going to be a session handling action extension. So what we want to do first is we're going to focus on, let's pretend we already have an access token. We want a way to cache the access token and save it and reuse it until it's no longer good. To do that, we're going to create a session handling rule, and we're going to tell the session handling rule, hey, for every single request, I want you to execute my JOT token session handling action. And it's going to take care of updating the request with those tokens. That's just what it's going to do. You don't have to worry about any kind of special rules. The extension is just going to do everything. Don't do anything special. But after doing that, we're going to look for the case when that token is no longer valid. And there's a built-in session handling rule called check session is valid. When you add that check session is valid session handling rule, you can configure it to say what a invalid request looks like. So it's gonna send the original request to the API/users endpoint, and then we're gonna tell it, I want you to look in the HTTP headers, and if the response back from the API users or for any request to the application contains a 401 unauthorized header, we got logged out or the JOT token expired. We need to do something. So the next part says, what is that something we need to do? Well, if the session is invalid, I want you to run a login macro. And I'm going to show you what that login macro looks like. Settings, sessions, and then macros. So if we want to add a login macro, we're going to click add, and we're going to go through our history and try to find a request that does that login thing. I've already done that. It's located right here. I gave it a name. It's called admin login -receive jot. And what you're going to see in here is a request from the proxy history to REST user login with our SQL injection payload to login. And we get a response back containing the jot token. This is sort of a template request for it to basically request a new jot token. And so we can configure our session handling rules in here to say, if the session is invalid, run that login request template. And we're going to get back from that login request template a jot token. We need our extension then to extract the inside part of that jot token. And we need to cache it in that current access token. That's what we were talking about over here. We have that current access token. This is where we're going to get it from, how we're going to cache it. So we're going to cache that current access token. And then again, we're going to apply it to the current request, and it's going to reissue that request. This check if session is valid session handling rule, it actually does that part for us. We update the header and the cookie. It goes ahead and resends that request that it knows is invalid and treats it as if it was the original request. So let's look at how that works in code. All right, so we're going to look at the jot token handler extension file. In here, it has a lot of things you're familiar with. We're going to have the name of the class. It's going to implement the Burp extension interface. And our entry point for our extension is the initialize method. So far, nothing's different from the template. We're going to check to see if API is null. We're going to store a copy of the Montoya API. We're going to call our plugin jot token handler. And the thing that's new is we're going to tell Burp Suite that we have a session handling action for it to use when we have that pop-up menu. So we're saying, hey, we have a session handling action, and the class that implements this feature is this current class. In order to be able to point at this current class, saying that it's the one that's going to provide this feature, we have to implement the session handling action interface. So much like Burp extension, there's an interface specifically for session handling actions. Now, when we implement that interface, if I control click, we're going to need to have a function called name, and we're going to need a function called perform action. So we need to provide that in our class. Let's look at how those work. The name one is pretty easy. We're just going to return whatever name we want. This is the jot token session handling action. And the place you're going to see that actually where you're going to see that is when we go to our session handling rule and we edit it. We mentioned that we're going to first invoke the session handling, the session handler action. If I edit this, we're going to see a drop down of all registered session handling actions, and whatever returns from that name function is going to be the name of that session handling action. So in this case, it's that jot token session handling action. We also see that same one down at the bottom of our check if session is valid, the jot token session handling action. That's how it's kind of appearing or being available inside of Burp Suite. Back to the code. So we also said that we have to provide a perform action function. This is the method that's going to be executed whenever we have our session handling rule run. So when it receives a request the first time, go back to slides. When it receives the request the first time, this part in red, it's going to run that perform action method. But also, when we get down here to the bottom one, it's going to be running it there as well. We actually have two different cases where we're running it. We're going to apply the current access token in one case. In the other case, we're going to scrape the current access token, or jot token, sorry, from the response of the login request, and we're going to cache it as the current access token. And then again, we're going to apply the current access token. We're going to need to do both things in that case. So we have two sections of code to address that. The first one is we're going to talk about processing the login request. So when we run perform action, if we have any kind of login request, any kind of session handling macros or login macros that get run. The action data.macro request response collection is going to be non-empty. There's going to be requests and responses in there. There could be one set, there could be 10 sets. In this case, what we're going to do is we're going to iterate through any of them, and we're going to check all the responses. So check to see if there is a response. And we're going to check all the responses to see if it matches a certain regular expression. So the regular expression that we're going to look for is defined up here as a property. We're going to look for something that says token followed by 0 or more spaces, a colon, 0 more spaces. It's going to be, the jot token is going to be surrounded by quotation marks. And then we're going to have a regular expression capture group, which allows us to extract out the things in between parentheses. We're going to say, hey, we want that thing inside of the quoted token parameter, and we want to be able to pull it out. So we're going to be able to retrieve anything that's in the parentheses here. So if we come back down to our code, we're going to say in the response, match that regular expression. And then with the result, we're going to say, did we find a match? And if we did we collect any kind of data inside those parentheses? Is there at least one thing we matched inside those parentheses? If so, we're going to grab the very first one, and we're going to cache that jot token that's inside the parentheses into our access token property. So if I control click the access token property, at the top we have this private var access token of type nullable string. It starts out empty. That's where we're going to put the access token and reuse it for every request until it no longer works. So again, that part covers just this part. We logged in, we got a jot token, our extension ran, it cached the current access token. So we're only as far as that right now. We also need to apply the access token to request, both here and here. We're going to do that in the perform action after that other code. So this is the code we talked about. Underneath that is when we're going to check to see, do we have an access token currently? Is it non-empty? And if it is, we are going to create a new authorization bearer header with that jot token. And we're going to update the cookie with that jot token as the value for that token cookie. And that's going to update a current request, allow us to send a authenticated request to the application, and be able to kind of use repeater or intruder or scanner without having to manually update that stuff. Let's actually look at an example demo of doing that so that we can see it in action. Actually, before I do that, I also want to point out when you are creating the session handling rules, you need to go to the scope section. You need to tell it which tools you want to be able to use it. And you need to tell it to use it for all URLs, or if you have a scope defined in your project, use it for the suite scope. But make sure that you configure this, otherwise nothing will happen and it won't actually work. All right, let's go to repeater. Actually, we're going to open the session tracer as well to sort of show some troubleshooting you can do. I'm going to open that. And repeater. Okay, let's start with trying to query the API, and we're going to get rid of our cookies and our authorization header and show that it does not work initially. If I hit send, it says, hey, there's no cookies or headers. This is not working. I'll make sure I actually have that session handling rule check marked as well before we go into this. All right. So let's go ahead and log in now. So our Burp extension is going to listen for, oh, I'm sorry. No, that's not what we're going to do. We're going to stay here in the user section, and we are going to, actually turn on our extension. Okay. Now, when I hit send, it's going to automatically log in and update our authorization header and cookies, and then send a successful request to the /API/users. It's taking a little longer than normal, and you can see at the end it appended a bearer token and it created a new cookie, and then we got back a successful request. If I look at the session tracer, we can see this happening one step at a time too. So if you need to troubleshoot something like this, open the session tracer, and it's going to go and execute each of your rules. So we have a rule called add jot token. That's the group that has each of our different rules in it. The first rule is to run the session handling action. Let's see if we can make this a little bigger. Okay. So it's going to issue the current request for the session. It's going to append the session handling or the authorization bearer and cookie tokens if it has one, but it doesn't yet. It doesn't have those cookies, so it can't do it. It's then going to have a response. We got back a 401 unauthorized, and it recognized it as the session being invalid. So next, it's going to run the login macro. So it is going to issue this login request with our SQL injection attack to log in. We're going to get back a jot token, and to show that it really is this specific jot token, I'm going to copy it, and we're going to put it in here. All right, now it's going to scrape it out, and then it's going to reissue the request. If you notice, this is after running our extension. It has that specific jot token in here now. It's going to reissue the request, and then it's going to come back with a successful response. So step by step, this is how the session handling rules are running and what's happening with each step. Now, if we were to run this again, we want to check to see if the cached jot token is being used or if it's relogging in every single time. So let's do that again and verify. So I'm going to delete out the cookies again and the bearer token. Okay, and I'm going to hit send, and notice the request is a lot faster than last time. Let's go to our session tracer and find out what it did. So here is the next request. It says issuing request, and you'll notice that it already has that jot token in there. Remember, we deleted the jot token, but our, oh, I'm sorry, I'm actually looking at the wrong one. So here is where it actually has that same jot token. We had deleted this jot token from the repeater tab. It added it back in using our session handling action. Then it ran the check if session is valid, and it says, hey, I did not get a 401 unauthorized. It is indeed valid. It did not rerun any login macro. It did not reissue the request. It simply applied the current jot token to the request and ran it, and that was it. So this is going to kind of make life a lot easier for using a lot of Burp Suite's tools in an application that has some custom authentication that can't just be scripted up in a session handling rule stock without some customization. This is how you can kind of customize that. Before I show you kind of the next step, I actually want to show you one of those Kotlin features that I used that I kind of glossed over. When we went to go and add or update the header and cookie, I actually used a Kotlin extension function or monkey patching to do this. If I were to actually click on this add or update header, what you'll notice is I'm actually inside of my own class or a file, hbrequestpatch.kt. So if I go back, just to kind of emphasize this, I'm looking at a HB request class here that I'm interacting with. If I look at the HB request class, notice that it's part of burp.api.montoya.http.message.request. This is from the Montoya library. This is not my code or my class. And so I have chosen, though, to use extension functions to add a function that didn't exist previously. Add or update header is not a Montoya API function. It does not exist. But if I wanted to add it, I could come over here and create a new file. I called it HB request patch. I could import the HB request class from the Montoya API. And using Kotlin, I could say, hey, I want to add to the HB request class, I want to add this method that doesn't yet exist. And I can define what I want it to pass, and I can say that it returns a copy of the HB request. And I can add functionality onto the top of their API. The reason I did this, though, is because, well, I couldn't figure out why something wasn't working for a long time. And then I eventually figured it out. So when you add or update a cookie or a header in Burp Suite, you have to figure out if that header or cookie already exists and then use the correct function. If you say update a header, and the header doesn't exist, it will not update the header. Nothing will happen. No new header will get added. Nothing happens. Same with the cookies. If you add a cookie, or if you update a cookie that doesn't exist, it will not add the cookie. Nothing happens. It silently just does nothing. And so when you use these functions in the Montoya API, you have to first check to see if that header exists or if that cookie exists. And if it does not, you have to add the header or add the cookie. If it does exist, you have to update the header or cookie. I didn't want to have to worry about that logic, so I created an extension function that basically does that for me, and then I don't have to think about it very much. This is actually inside of a shared library that I'm making available to you all that I'll talk about here in a little bit. Okay, so we have this really cool session handling rule thing, and it works great, but there's a hard-coded regular expression in here. There's a hard-coded cookie name. There's a hard-coded header that may not be true for every application. And it would be nice if we could reuse this. It'd be nice if we didn't have to like pull out the really, really specific extension that we created just for this application when we come back and retest it in a year. So how can we make all this configurable, and how can we do that easily? One way to do that is with persistent settings. In the Montoya API, Portsugar added the ability to save settings in the project file. You can also actually save settings in Burp Suite, but I'm going to focus on saving settings inside the project file. And if we could save settings for what that regular expression looks like, what the name of the cookie is, what header we should use, all that kind of stuff, that would mean that we could write one extension and use it for all of our assessments. And we don't have to like dig out the right thing. And in fact, when we open up the project file in a year to retest or do a follow-up assessment, the settings are still there. We'll open up the extension and it'll just simply work. How do we make that happen and do that easily? I actually wrote a library that gives you these settings for like with really easy code, and actually gives you a user interface to do that as well. So we're going to take a look at that. First, let me demo what it looks like. And it turns out we've actually been using it the whole time. If I, so the way mine works is you go from a right-click context menu to open a settings system, and then you can see the settings, modify them, and save them. So if I right-click on a request, go to extensions, go to my jot token handler, there's a settings menu, and I click on it, and up pops a dialog. And in the dialog is each of the settings that I've defined, which I'll show you shortly. So we have the name of the authorization header. We have any prefix that comes before our bearer token. We have the regular expression to extract out the jot token, which we could change. Let's say some applications look for access dash token. Some are access capital T token. We can go and customize this for the specific application that we're using. And then the name of the cookie is here, and then whether or not we want to use a header or want to use a cookie is here. We also have default settings, so if you kind of mess with them, come over here and hit reset, and it'll reset it to the default setting. We then click save, and it's actually going to save it to the project file, so the next time we open the project file, these same exact values will be here. It will not change if you open a different project file or start a new assessment. It's going to come with your .burp project file. So how do we actually implement that? A lot of times doing UI stuff in Burp Suite is really, really tough. So let's look at what the demands on the developer is to produce that. First, we're going to start with the settings. How do you define those settings? So I have a library I've created. And actually, let me go to Firefox real quick to show you. So under that Burp, Kotlin Burp extensions base GitHub library, this is a link to all the things that you're going to need. If you look all the way at the bottom, there's a Burp Montoya library. If I click on that, you're going to find documentation for all the things that the Burp Montoya library provides. One of those things is settings and a UI for being able to update those settings. It's going to provide example code for how you make that work. There's a number of other things in here as well to look at, but we're going to focus on the settings for now. So, and the way we add that to our project, I have this on jetpack.io is where my repository is. you end up uncommenting out this from the Burp template, and then you have to uncomment out these lines from the Burp template to make this work. Once that's in place, you can then define some settings. We have, in this case, Boolean and string settings for extension. There's a couple other options. We just need to create a setting for each of those things that we saw in that user interface. So we're going to declare them as properties up top, and then we have to wait to initialize them inside the initialize method. So when we initialize the settings, we're going to create a new string extension setting, for example. We're going to pass a Montoya API instance. We're going to give it a name. We're going to give it some kind of unique value to store as like the key for the project persistence setting. We want a default value, and then we want to tell it, we want to save it in the project file. You could save it in Burp's global preferences. I don't think that'll happen very often. So you'll save it in the project file here. And you just repeat that for each of the settings. So we got header name, header value, whether it should update the header, what the cookie's name is, things like that. After you define your settings, you're going to then create a list of them so you can easily hand them off to a UI generator. So our settings are in the extension settings variable. And then I have some classes that have built-in user interface generation for you. You're going to hand off your list of settings and the name of the dialog to this generic extension settings form generator. You're going to tell it to sort of build it and then run it. And then from there, it will actually pop up just like we had before. This is not the right-click context menu part. This is just building the UI and having it show up the very first time you run or load the extension. The right-click part comes from this line right here. We're going to register a context menu item provider, and I have a class that already does everything you needed to do. You just pass in the Montoya API instance and your form that we got from the form builder up here. And then you'll have a right-click context menu to be able to update that setting whenever you want. And then last, the other thing you need is a register unload handler, which I provide the class for as well. It turns out when you unload your extension, the UI doesn't go away. It sticks around in memory. And if you don't close it, it sticks around in your Windows environment or your UI environment. So we needed something to actually unload that whenever we unloaded the extension, and we have to actually do that manually. That's what this does. So this is the entirety of the code for storing settings, and the definition of these up here. This is all it takes to generate UI. You didn't have to mess with JFrames or JPanels or labels or grid layouts or any kind of crazy swing UI thing. You didn't have to do any of that. It all happens automatically. And I want to kind of give credit for that. I am not the one actually doing this. I'm using a project called UI Booster that generates these user interfaces for you. I just basically hand off what I want those to look like to UI Booster, and it builds the user interface. Okay, so next we have a bunch of settings. We can modify the settings. We can save the settings, and they'll stick with our project file. How do we use them when we actually have our session handling action? So I'm going to go down to our perform action method, and we're going to see what it is I changed about that to make that happen. If we go down to our code, it's largely the same. Right here, we had a reference to a property for the regular expression. Now we have a reference to our access token pattern regex, and we just say, I want the current value from that setting. Same thing down below. We need to reference the name of the header, the name of the cookie. We want to reference the prefix for that authorization header. We just reference the setting and call .currentValue. So this part really doesn't change. There really isn't much different here at all. And that is all it takes to be able to make this reusable and to travel with your project file to be able to apply to any project you're doing. If you at some point find that there's something it doesn't quite do, you can add to it and make sure it's just backwards compatible with the previous stuff you've done, and keep using the same extension year after year to do this particular function. So this extension is an example of one that is probably almost something, does almost what you need in your current project. If you're a pen tester and you don't want to start from scratch, and you're not sure what it's going to take to be able to accomplish a certain thing, you would start with a project like this and come here and update some specific sections of code instead of starting from scratch, and to be able to quickly be on your way with being able to do your pen test. If we go back to that Firefox window where we have our Kotlin extension base, down here is a reminder. I have a bunch of example extensions that do some of the things that you might need to do in your project. Come look at them and how they work. See if one of them is almost exactly what you need with just a little bit of customization. Maybe you can use it straight up on your project. Spend very little time being able to do what you need to do. Yep, so with that, I have a few resources that I can talk about. If you want to learn more about how to use Kotlin, I have a couple of resources on the slide that I used. I used a lot more than these, but these were really good starting points. There's also some example Montoya API extensions in Java, though. So we have the API documentation, which is you really need. But then Portswigger has a bunch of examples that are written in Java for how to do different tasks. And this is a starting point for being able to write one with Kotlin. It's going to be very, very similar in Kotlin. The link to my Burp extension base GitHub repository is on this slide. So that's your starting point. Clone that or download a zip and use that as a starting point, or scroll to the bottom of the page and look for a template or an example plugin that's already built that does what you need. And then last, consider joining the Portswigger Discord. It's a community, Discord community, where we talk about building extensions or web app pen testing, and we ask people for help or give advice or just kind of share code. BAM does extensions and things like that. It's a really great place to be if you do a lot of app pen testing. With that, thank you for joining me for my presentation.